So let us just create a little wave. Okay, so we need 20 people. Okay, and each of them has something like this vertical bar. Okay, it has a blue side here. The top side is blue, and the bottom side is red. You just move it up and down. Okay, you move it up and down. Whenever it's above my fingers or above the horizon, it's blue, and whenever it's down, it's red. It looks like this. Not very good, but anyway. So this is what you do. Okay, this is a wave oscillating up and down, and then the next person next to you does the same, but with a little bit of a delay. So now if you consider a situation like this and you produce a little animation, this is how it looks. This is how it looks like. This is a wave. A wave is an organized pattern that apparently moves into a direction without net movement of material into that. So there is nothing moving because all I do is actually move a bar up and down, okay? And there is no horizontal movement. And the apparent horizontal movement here in this example is actually called the phase speed. You can see some movement to the right. This is what we call the phase speed of the wave. So in the oceans, it's a little bit different because there's actually something moving, and this is the force that actually creates the wave. It's the shape of the sea surface, which is moves in space. Okay, and wherever it goes, it actually produces a force that accelerates the flow. Okay, but I don't want to confuse you too early. Let's just have a look at the fundamental properties of wave. Okay? So this is about the sinusoidal waveform. This is the most basic way you can describe a wave. Okay, with a formula. You can see it's a formula here. We call the wave A. Okay? And A is now the disturbance that you talk about. Okay, so how much above the horizon, how much below the horizon? This is your elevation. Okay? And then you can describe it in terms of three properties. A0 is the amplitude, this lambda here is the wavelength, and this capital T is the wave period. And the variables are space, and one dimension here in this example is x, and time is t. Okay? And this is how you describe the wave. And if you think about this, and if you walk around with this little formula, and it also includes a description of the phase speed. And the phase speed of the wave, of any wave, is c, is the ratio between wavelength and wave period. And you can reformulate the wave, or move a little bit away. Here you can rewrite this formula up here, and we actually can make use of this relationship c. Okay, the phase speed in here. And then what you learn is that what the c does, it just translates the signal horizontally. Okay, so this is what we call the sinusoidal waveform.